Welcome to myprojectbazaar.com. Project title: Detecting and Tracing i.i.d attacks in networks with any number of relays. Now see the abstract. The cooperative network promotes coverage and cooperation diversity under the assumption that each relay is trustworthy and cooperative completely. However, relays are potential to be malicious by forwarding garbled symbols in practical scenarios. In this case, the malicious relays should be excluded from the cooperative network to prevent the corruption of communication and guarantee the performance of the cooperative technique. In addition, the existing schemes are implemented at the source node, which makes it difficult for the destination to discard the symbols forwarded by malicious relays. Thus, it is essential to detect and trace the malicious relay nodes if they exist in the routing path. Hence, the proposed system investigates the detection and tracing problems in a multi-relay network, where a source wants to exchange the information with a destination through multiple potential malicious relay nodes. In such a multi-relay network, communication is established between a source and a destination with the aid of multiple relays which are potential to be malicious. Once the source and destination are created, channel is assigned for the transmission of packets within the relay. The source node forwards packets in the route with the help of the control packets. The malicious relay is detected in the route by tracing the behavior in pinpoint of the route between the source and destination. Simulation results shows that the proposed system performance is increased than the previous system techniques. Now see the flow of our process. First, the network model is created with the number of nodes. Then, the source and the destination nodes are created. Then, the multiple relays are formed in the routing path. After that, the routing procedures are to be executed. In this, using the control packets, the neighbors are find out and advertise the neighbors to find out the exact routing path. Then, the trace path. This trace path is find out for detection of the malicious nodes in the route. If the malicious is present means it again trace path, that is it chooses another path for transferring packet. If no malicious in the route means it performs the packet transmission. Finally, the performance is evaluated for the proposed process. Let's see the output demo. First, open the terminal window, then go for the directory. Then for the run the code, type in a space file name, that is main.tcl. The 50 nodes are created and the routes are all updated for each communication in the network. These are the routing path execution to trace the malicious. So this is the NAM window. Here the network is formed with the transmission rings. The nodes are deployed here. The source and the destination nodes are created. This is a simulation time running. Between the source and destination, the routing path 1 is formed and the second routing path is created. Then the third routing path is created. There are three routing paths are formed between the source and the destination. Now the relay nodes are created in each path in the network. Now the communication starts between the source and the destination nodes. It selects the routing path such as 7 to 6, that is 70, 40, 24, 44, 1 and 6. Here the relay node is act as the malicious nodes which drops the packet instead of forward to the destination. By tracing this malicious behavior, the source node have to choose the another path. Now it changes the path and selects the another routing path between the source and destination. Now it selects the path as 7, 46, 8, 45, 9, 43 and 6. This route is efficient for the packet transmission. So now the packet reaches the destination. The packet transmission is successfully between the source and the destination. To see the performance results, back to the terminal window and type awk -f delay.awk then out.tr. So with the help of the AWK script and the trace file generator, we have to calculate the performance of the delay. So to see the graph results, type xgraph space delay.xg. This is the delay graph that executed in here. The number of packets transferred are all plotted with the number of packets received. This delay is calculated for the proposed system for each and every packet transmission. That's all. Thanks for watching.